Hello there, welcome to this podcast, and we're going to attempt a physics paper this time. We did a biology paper, and we're going to attempt a physics paper. So this is a paper you should have already done, so it's a matter of you going through and seeing which bits you've got right, which bits where you put the marks up, and where you may have dropped a few marks in correcting it. So ultimately, at the end of this activity, you've got a fully answered paper, some with your answers hopefully, and some with my answers if needed. So physics is important to remember. You do have this formula sheet. This formula sheet will be separate in your, it won't be blue, it'll be separate in your examination. Just for photocopying sake, we've put it on the front. So you'd have this actually side by side to your answer paper. Okay. Turn over. Again, technique-wise, this is about current and electricity. So filling out, this is a complete question. So there's your command word, what do you need to do? I just need to put a cross somewhere. The current in the filament lamp is a flow of electrons. Electrons are negatively charged, and that's what electricity is, a flow of electrons. Right, state what is measured by the meters. So we've got a circuit. So it's just saying, do you know what goes here in a circuit, do you not goes in? Which meters are they? You only know 2 meters, and that's a voltmeter and an ammeter. So which way round? It's a 50-50 ultimately, but hopefully you know that voltmeters go around things, go in parallel to things. So meter 2 is a voltmeter, meter 1 is an ammeter. Okay, so we're going down the question now, so it should be getting a little bit trickier as we go down. So first calculation question. This is putting numbers into equation. The normal operating potential difference of voltage and current of the filament is 6 volts and 0.4 amps. So I'm going to circle this, and I'm going to circle this. That's the numbers I've been given. Calculate the energy supplied to the lamp under this condition in 20 seconds. So now I've got to look at this. In your case, you'll be going back to the front of your paper. But in this case, I'm looking at which one gives me energy. Energy transferred. Look, energy here. Current. Well, it mentions current in the question, doesn't it? Yeah. Potential difference. Oh, it mentions potential difference. Great. This could be the one because seconds, time. Brilliant. So now I know which equation to use. Select the right equation. And it says energy equals current times voltage times time. So it's a case of timesing those numbers together. So current, it tells me, is 0.4 amps. See, I'm putting them directly underneath just for my sanity. 6 volts. So I'm really ordered. Now times them together. So 6 times 0.4 times 20. Oh, that's not right. 0.4 times 6 times 20. 48. 48 joules. There you go. Simple as that. And now we'll have a graph look. The graph shows how current varies with potential difference for another place. So you should know the shape of this graph anyway. We've talked about shapes of graphs. And there's another couple of graphs that you need to know the shape of. And hope they will come in different papers. But calculate the resistance when the current is 0.3 amps. And it's giving you the equation. You don't need to go and look for the equation. It's giving it you there. So we need numbers though. So if you write resistance, potential difference divided by current, well, it's given me current. So that is 0.3. So I'm after the number to divide 0.3 by. So at 0.3, I go across, I come down, and I hit in between 2 and 4. So you know that in between 2 and 4 the number lies 3. 3 divided by 0.3 is 30. You don't need to calculate that, but do it on the calculator. If you know the numbers, it's good that you know it. Oh, it's wrong, see? 10. How bad's my maths? So that's a perfect example. I made that mistake on purpose so you could see that don't just assume an answer. Of course it's 10. There you go. Question 1, done. 8 marks in total. Let's shift on to question 2. So, momentum, work and energy. So it gives you a heads up on what this next question is going to be about. Right then. Only one of these is a vector. Now vector means where direction is given. Where a direction is given. So energy, momentum, power and speed. Now in our lessons you've just got to recognise and realise that momentum's got a direction. Speed hasn't, velocity has. Okay? So it's not speed, it's momentum. And then complete the sentence by using the word from the back. So we're still on there, so we've used momentum. The rate of work done is called power. Now that should be through elimination. It's not going to be speed, not going to be energy. It doesn't make sense there. It's got to be power. Let's turn over. Oh, another equation. We're already on. This is we had 5 on the previous page. This is 8 marks so far. This is the 8th mark for equations. Right, javelin has a mass of 0.8 and one throw. So mass, velocity. Calculate the kinetic energy. Off I go. Get my formula sheet. Kinetic energy. There it is, look. Kinetic energy equals half times mass times velocity squared. So it's a half times mass times velocity squared. So now I just need to write this out. So a half is 0.5 times a mass, 0.8, times 25 squared. So I would do another line here after doing the 25 squared, which is 25 times 25 equals 625. So then I put them all together. 0.5 times 0.8 times 625 equals, that's wrong, 0.5 times 0.8 times 625 equals, it's right, 250. That will get me 2 of those 3 marks. But the unit for energy is joules. State the amount of work done. Right, okay. Work done. And I'm given velocity. Right, so let's have a look at work done. Work done is force times distance moved in the direction of the force. So, state the amount of work done. Right, this is a bit... See, now, if it says state and not calculate, here, I haven't got to do a calculation. This is actually testing. It's a bit cheeky, this one is. It's actually testing you. Do you know that work done is the same as energy transferred? So, the actual equation for this is energy transferred. This is from your notes. Is the same as work done. So the work done is 250 joules. There you go. Right then, a good javelin thrower will try to extend their arm as much as possible before we explain why this allows them to do more work. Well, if you look at work done, it's force times distance moved. So the athlete is going to be able to apply a force, but if you increase the distance moved having a straight arm, so if you throw the javelin from there, as opposed to straight arm from there, I've got a bigger distance to apply my force, you see. So, using the equation is the key to this answer. And you'll say, by applying the same force over a larger distance will result in more work done. Bing. Okay, and then it'll go, well, I suppose, which means it will travel further. Okay, 8 marks. Static electricity. There's always a question on static. Get to know your static. Dead simple if you want to know it. So we've got these 2 balloons here, negatively charged. The balloons something each other. Well, opposites attract and like repel. So the word repel goes there. Because they have the same charge. The cloth is left with A. So if these have got negatives and they've got to have come from somewhere, so the cloth is going to be left with a positive charge. Because the cloth, before being rubbed by the balloon, will have, I don't know, let's just say that. Okay? but those negatives have gone to the balloon. So the cloth, once those negatives have jumped to this balloon, the cloth is just going to have positives left, and it's going to be positively charged. The charged particles that enter are called transfer from the cloth. So what's making it negative? What has a negative charge? The electrons. 4 marks for understanding static electricity. If you think about it, you get a 6-mark question on this paper. You get 2, in fact. And everyone gets a nick and a twist about it, and it's 6 marks. But think about how easy these 4 marks are. Okay? You give you out time, a lot of you, for getting 4 out of 6 on the 6 marker. But you're just picking up these 1 marks here and there just by knowing your stuff, just by revising. Let's turn over. Right then, so the diagram shows an electrostatic insecticide spray being used on a plant. The plant is initially uncharged. Each droplet of spray is given a positive charge. So every droplet of spray has got a positive charge. Explain the advantages of using electrostatic insecticide spray compared to an uncharged spray. Right, okay, so we've talked about this using spray paint. We've done it lots. We've talked about spray painting cars, haven't we? So they've given you a different scenario, principle still the same. So why did we say? So even spread of insecticide as the particles repel each other as they are all positively charged. I've got 2 marks in there. Repel each other, positively charged. And the last mark is more chance of the insecticide, just like we said with the cars, sticking to the plant. So less wasted. Okay. Right. Oh, another question on calculations. 3 marks. So if it says 3 marks instead of 2, then I've got to do a bit more work here somewhere. So let's have a quick look. There's a current of 0.8, so I've got given current. I've got given a time. Calculate the charge supplied and this so charge. So where's charge? Charge is current times time. Current times time equals charge. So current is 0.008. Now time, I'd imagine, is going to be in seconds. And I imagine it's going to be in seconds, so we've got 3 marks for this. So I've got to do something extra. So what is 10 minutes in seconds? Well, every minute is 60 seconds. That makes 10 minutes 600 seconds by my reckoning. Am I right in saying that? 1 minute, 60 seconds, 10 times 60, yeah. Right, so, put this together, 0.008 times 600, 4.8 coulombs, done. Well, that's half of the paper done. I think at that point I'm going to stop, okay, and I will do a follow-up to this. To get the rest of the paper. So we're halfway through the paper now, and how many marks? 10 and then 2, 8, 16, 26. So just shy of half the way through. Okay, so we've got 26 marks up for grabs then. So I'm only about another 4 marks off getting a grade C for this paper. And I've still got half the paper to go. And we haven't had motion and forces yet. So I might just do that, you know. No, I'll leave it. I'll do that second installment. Okie dokie. Thank you. Goodbye.